Hi students, in this video we're going to be talking about Linux File I/O and some of the basics of how to use File I/O in user space in Linux. So we're going to introduce Linux File I/O, we're going to talk about buffered I/O versus system calls, and we're going to deal with the most basic operation that you're going to do on files, which is opening them. So files, in terms of how you're interacting with the kernel, files are going to be opened via what's called file descriptors, and you often see this abbreviated as FDs. And an FD is really just represented by an integer. So both the kernel and user space are ultimately referring to files based on an integer value that's tracked in the kernel. So the kernel is going to maintain a per process list of files in a file table. So every process is going to have its own custom list of files based on which file it's opened. And that list of files is going to be indexed by the file descriptor, which again is just an integer. Every process in Linux is going to have at least 3 file descriptors open when it was created, that is. The first is standard in, which is the standard input, and this is by historical precedent file descriptor 0. And so this is what your terminal input device, if you're using the terminal to interact with your program, this is where you're going to be typing input in from the keyboard. The second is standard out, which is file descriptor 1, and this is the terminal display. So if you're looking at printf output, this is where your printf output is going to be going to file descriptor 1. And then the third is standard error or file descriptor 2, and this is also going to be redirected to the terminal display, but it allows you to separate which print output goes to possibly different targets. So this is useful because if you're having an error occur in your program, you can send that to a different path than normal standard output and then possibly capture that separately. So the output file descriptor 2 is where that error messages are typically sent. So you're probably familiar with, if you've done any type of POSIX programming before, you're probably used to fopen, fwrite, and fread. And that's typically what you'll use if you're just writing a hello world type program and looking at examples. So one of the things that you'll notice when we're talking about Linux system programming is that we're using the ones that don't have the F prefix. We're using open, read, write, and close. So the reason we are using the ones without the F prefix is that the F prefix functions relate to buffered I/O and not system calls. So again, in this class, what we're going to be talking about is the interaction between user space and kernel space. F calls are one step above the system call level interface and interaction with the kernel. So there's another layer of buffering that's happening there. So those are useful. You would typically use them in programs, but we're going to talk about the open or the non-F prefix versions of file I/O, just because that's where the interaction is happening with the kernel. So the non-F prefix are the ones that are going to be using system calls. So one other thing that you'll notice when you look at the call signature of open versus fopen is going to return a file pointer, and the syscall version of open is going to return that file descriptor that we mentioned. And so this is what's actually happening in terms of the kernel and user space interaction is an integer tracking. And that gets abstracted into a file pointer when you're using buffered I/O. One other way that you can see the difference for this, using the man pages that I described, and if you remember when we originally talked about man pages, I talked about the fact that you can look at the corner here and see references to the original Unix programmer specification from back in the 1970s. And so one thing that you'll notice when you look at these two different man pages is the fopen is actually in a different section of the manual. And so because it's not a part of the syscall interface, it's actually in section 3 of the manual, whereas the open functions are in section 2 of the manual. So again, just an indication that we're dealing with a different layer when we're looking at the fopen or the F prefix version of file I/O. And if you dig into the source code for glibc, you can trace it down to the point that you can convince yourself that fopen calls actually are working with open calls under the hood. And so here's an example of following the path through from where fopen is actually defined and used in glibc, and where it's actually calling the under open command that maps to a system call under the hood. So we can verify that fopen is really just a wrapper on open that's going to add buffering. So again, the difference between the fopen and open is just that the fprefix functions from standard I/O are going to provide the platform independent user buffering. And what if you there's more details on this in Linux System Programming Chapter 3, but ultimately file buffering just means that rather than reading and writing a full block, you're going to be reading and writing copies in memory, and that can improve performance. But what do we specifically mean when we say user space file buffering? We mean that in the F function cases, that buffering is actually happening in the user space rather than in the kernel. So one benefit there is that you can reduce the amount of system calls made into the kernel. And there's more details on this again in Linux System Programming Chapter 3 if you want to probe into this in a little more detail. But and it's fine to use the F-based functions in your programming assignments. Again, we're talking about the non-F prefix ones just because we want to talk about the details of the user space and kernel interaction for the purpose of this course. So the open function, again, maps really close to what you're used to if you've already used fopen. And really, we're just matching a path name to a file descriptor. So when we pass in open to a path name of a file that we want to open, we're going to be returned a file descriptor we can use to reference that file from within our process. So the flags that we can include are related to access, whether we want read-only, read-write, if we want to create, append. There's a bunch of other things we can do like synchronous I/O that we'll talk about in later videos. And then when you are creating the file, there's a mode argument that you can use that gives read, write, or execute permissions for user group or other, as we've already discussed, using the Linux permission scheme.